Now that the backend rack pipeline is ready, the next step is to build the user interface. First of all, you clone the repository for the front-end code. I have given the repository link in the description below. This is how the interface looks like. The front end allows users to interact with the AI knowledge assistant. They can ask questions, view responses, and upload documents that will be added to the knowledge base. Let's quickly walk through the structure of the React application. Just like the backend, the goal here is clean separation of concerns. At the root of the project, we have some standard front-end files. Package.json defines all the project dependencies and scripts. We are using Vite as the development server and build tool, which keeps the development environment fast and lightweight. Vite.config.ts contains configuration for the Vite setup. Index.html is the entry HTML file that loads the React application. We also have .gitignore, readme.md, and configuration files like postcss.config.mjs. The main application code lives inside the src directory. Everything related to the React application is organized here. Inside src, we have an app folder. This folder contains the main structure of the application. You can think of this as the application layer of the front end. Most of the UI lives inside the components directory. Each component is responsible for a specific part of the interface. Instead of one large UI file, we break the interface into reusable pieces. Let's look at the key components. Chat interface.tsx. This is the main container for the chat system. It coordinates the different UI elements involved in the chat experience. For example, the sidebar, the chat message area, the input field, and the upload modal. You can think of this component as the main orchestrator of the chat UI. Also, if you can see here, I am referencing the Vite API base URL, which is nothing but my RAG agent server URL. Chat input.tsx. At the bottom of the interface, we have chat input. This component handles the message input field. When a user types a question and sends it, this component triggers the API call to the backend chat endpoint. Sidebar.tsx. The sidebar contains the navigation area of the application. In our design, it shows things like the application title, the previous conversations, and the option to upload documents. This keeps the chat interface clean while still allowing users to manage their knowledge sources. Document upload modal.tsx. This component handles the document ingestion flow from the UI. When the user clicks upload, a modal appears allowing them to select or drag and drop documents. Those files are then sent to the backend /upload API endpoint. Once processed, those documents become part of the knowledge base. Source tag.tsx. When the AI responds, it can include references to the documents used during retrieval. The source tag component renders those references. This helps users understand where the answer came from, which improves trust and transparency in the system. UI. Inside the components folder, we also have a UI directory. This contains smaller reusable UI primitives. Things like button, layout components, or shared styling elements. Keeping this separate makes the UI more modular and easier to maintain. Styles. The styles folder contains the styling setup for the application. Here we define global styles and design tokens used across the interface. Routes.ts. This file defines API endpoints used by the frontend. This centralizes the backend URL so that components don't have to hardcode API paths. If the backend URL changes later, we only update it in one place. Main.tsx. This is the entry point of the React application. It initializes React and renders the root component into the DOM. So when the app starts, execution begins here. So that's the overall structure of the front end. Just like the backend, the goal is modular design. Components handle UI, API calls connect to the backend rack system, and each part of the interface has a clear responsibility. Now that we understand the structure, let's run the front end and connect it to our rack backend. I'm going to run the server from the terminal. Npm run dev. So the application is running on 5174 port. Let me go and check. Yeah. Now let me first try uploading a document. Let me browse the document. Let me try uploading all the three documents. Click on upload three files. So the documents have been uploaded. So as you can see, these were the dummy mock data, but if you ignore this, you can see that the documents with the actual PDFs have been uploaded and it is showing us the actual sizes of the PDF files. Now let me try asking something to the chatbot. What is the process to handle a P1 incident? Yeah, we are getting the response from the chatbot successfully. So it is saying, according to the documentation, the process to handle a P1 incident includes the following steps. So what happened under the hood? We tried to upload the document in the front end. It uploaded the document using the RAG API, upload API. And then we tried to query a question through the front end interface. So the front end interface passed that query to the RAG agent, which is running in the backend. The RAG agent calls the LLM, does all the necessary steps, for example, the chunking, the embedding, and etc. And then it gives us the corresponding response from the PDF back to the front end. So the front end to RAG agent, the communication is established. Now it is time to enter AWS.